Welcome back to another training video using the UK electrical simulator. In this video we're going to look a little more closely at the ring final circuit, sometimes informally called a ring main. We touched on this in the previous video, but this time we're going to expand on it and look at spurs, fused spurs, and how to extend a ring final circuit correctly. Before we start, it's worth clearing up one important point. The regulations do not give a fixed maximum number of sockets that can be added to a ring final circuit. In practice, the design has to be suitable for the expected load and layout of the installation. You will often hear the figure of around 100 square meters, but that is best thought of as guidance for a typical domestic ring final circuit, not simply a rule that says you can add as many sockets as you like. Another common point is spurs. In general, you can add an unfused spur from an existing point on the ring, but that spur should only supply one single socket, one double socket, or one item of fixed equipment. If you want to supply more than one socket from that point, then you would normally do so through a 13 amp fused spur, sometimes called an FCU or fused connection unit. You can also extend a ring final circuit, but it has to be done properly. So let's look at this in the simulator. On the workspace, we already have a kitchen ring final circuit with 8 sockets. Now, although guidance is often discussed in terms of one spur from one existing point, in the real world you are unlikely to see every single socket on a ring heavily loaded with additional spurs. Even if something may be possible in theory, good design and common sense still matter. That said, it is perfectly reasonable to add a small number of spurs where needed. For example, the socket supplying the fridge freezer may be on an outside wall, and that location could make it a practical point from which to add an external garden socket. A good option would be to install an IP66 weatherproof socket. We can do this by drilling through the wall and feeding a 2.5mm 2-core and CPC cable to connect the two sockets. In the simulator, we can do that by taking the line, neutral and earth from the existing socket and wiring them through to the new outdoor socket. Another example might be adding an extra socket in a utility room. If the socket near the air fryer is in a suitable position, it may be practical to drill through the wall and add another socket on the other side. Again, we can show that here by taking the same 3 conductors across from the existing point. Now let's look at a different situation. Sometimes you may want to supply more than one additional socket from a single point. In that case, the correct approach is not to simply keep adding sockets to an unfused spur. Instead, you would normally install a fused spur. Let's say the microwave socket is on a wall, and on the other side of that wall is a garage. We want to supply several sockets in that garage from the existing circuit. For this example, we'll use a 13 amp fused spur. First add a fused spur and then add 3 sockets in the garage. Now make sure we have isolated the supply and then connect a line conductor from the existing socket to the line input side of the fused spur, and then from the line out to the first socket. Then connect a neutral conductor from the existing socket to the neutral input, and then from the neutral out to the first socket. And then connect the earth conductors. Now extend the conductors onto the remaining sockets and energize C2. We now have 3 sockets being supplied through a 13 amp fused spur. That means the downstream load is limited by the 13 amp fuse. If the total load on those garage sockets exceeds 13 amps, the fuse in the fused spur will operate. In the simulator, to reset the fuse, switch off one or more of the loads, then toggle the switch off and on. This represents replacing the blown fuse and restoring the supply. Now let's look at something different again. There may be times when you don't want to add a spur at all, but instead want to extend the ring final circuit itself. A good example would be a new kitchen extension, where extra wall space has been added, and 4 more sockets are needed to serve the larger room. Let's extend the kitchen and add the 4 new sockets and incorporate them into the existing circuit. To do that correctly, we isolate the supply and begin wiring the additional sockets. But this is the important part. What we must not do is simply add those extra sockets as though they are just another long spur, and then loop them back into an existing socket in the wrong way. To extend a ring final circuit correctly, we must break the existing ring at a suitable point and then extend both ends of the ring through the new sockets so that the circuit still forms one complete ring back to the same protective device. That is the key difference between adding a spur and extending the ring itself. So in this example, we have now successfully added a couple of spur sockets, added a 13 amp fused spur, and shown how additional sockets can be incorporated by extending the ring correctly. Even though this may all be acceptable in principle, we still need to think carefully about the actual load. A ring final circuit is typically protected by a 32 amp device, and if you keep adding sockets in areas such as a kitchen, utility room, garage, or even the garden, there is a greater chance of nuisance tripping or overloading the circuit, simply because appliances in those areas can draw quite a lot of current. So in many situations, especially if the cable route allows it, it may be better to supply an area such as the garage by its own separate radial circuit. Let's show that now. Make sure you have isolated the supply and remove the fused spur arrangement. Then add a new bus component and select C3 protected by a 20 amp RCBO. Now connect that new bus to the first socket in the garage. We now have the garage supplied by its own dedicated radial circuit, separate from the kitchen ring final circuit, which is often a much more practical arrangement. I hope you've enjoyed this video showing how a ring final circuit works, how to add spur sockets correctly, and when it may be better to use a separate radial circuit instead. Please like, subscribe, and leave a comment below.